Welcome to my talk, which is called Making Good Choices and Untangling the Yarn Ball of Open Source Java Dependencies. And thank you, Pujay, for letting me talk today and having me. My name's Theresa Mammarella. I'm a developer advocate at Sonatype. I've been in the open source Java space for a while now and have contributed to several JDK and compiler projects like OpenJ9 and Cubic, which is a Java static image prototype. And in my current role, I talk to Java developers about being more secure across their software development lifecycles. So Java's had a bit of a hard relationship with dependencies for a while now, including not being able to find classes all the time when necessary. The class path can be brittle sometimes, and class loading can be really tricky. But that's not what I'm here to talk about today. We're here to talk about dependencies more broadly. But this is just to illustrate that this can be a pretty challenging and frustrating problem to address these kinds of runtime issues. And it becomes even harder when considering the fact that the average application contains 128 open source dependencies. Our applications start to look a little bit like a tangled ball of yarn or a plate of spaghetti, and this isn't really that far from the truth. This is, in fact, a real dependency graph, which looks remarkably like this squiggly line here. And since I'm better at expressing logic than feelings, I've created this AI art for you to express the amount of dread you should feel when talking about these kinds of issues and these kinds of bugs that developers may need to face. You've likely all heard of the Log4Shell vulnerability by now, and 6 months after the fact, I like to think of it as this sort of dependency type of problem. Just to do a really quick overview, the Log4Shell vulnerability was publicized in December, and as a quick summary of it, Log4j is a logging tool that's used really often in Java projects, and it was found out that if you were able to figure out how to get user input as into logging variables, you could potentially use the JNDI technology to make a call to a remote server, which would then serialize a class back to you that could be malicious potentially. And the implications of this vulnerability were huge. A lot of Java developers had to work over Christmas. Anybody here had to give up some of your Christmas break for Log4Shell? A couple of you. What made this vulnerability so bad and why it keeps coming up time and time again is because it allowed bad actors to pretty much do whatever they want with a system if they're able to find their way into it. And the other thing that made it so bad is it's relatively easy for someone to exploit. So I work for Sonatype, and Sonatype actually manages Maven Central and created this dashboard to record what versions of Log4j developers were downloading. And this shows the downloads between the months of December, when it was publicized last year, and May. And as you can see, it got a little bit better, but not that much better. And by the spring, about a third of downloads of Log4j were still of these highly vulnerable versions. So what exactly went wrong here? Are Java developers living under a rock? I don't think that's the answer. This was a highly publicized vulnerability. Even my non-technical friends and family were asking about it, especially those who associate my job with the little pop-ups that come up on their aging Windows computers. They wanted to know even what Log4Shell was. Not only was it publicized in the media, but the Federal Trade Commission of the United States issued a warning that they would pursue legal action against companies who did not take reasonable action against protecting their consumer data. And what they were referring to in this one was, in particular, the Log4j security vulnerability. Well, what really happened here was transitive dependencies. And I'm going to talk about this term a lot, so just to make sure we're on the same page, when I talk about that, a direct dependency to a Java application is something that's declared in your POM file, something you're intending to use, that you know without a doubt and pretty easily is there. A transitive dependency gets pulled in by those libraries that an application may be using. And because of the way build tools help us abstract this problem away, it can be difficult to identify that they're there or really even care about them, just because it's been made pretty easy for us not to. And this is exactly what happened with Log4j. Application developers may have fixed the version they're using in their application, but that package could have been pulled in by all kinds of other areas. And there may be still vulnerable applications that may not be aware that they're in fact using them. And it's also extremely difficult, potentially, to identify that they're there. So my company, Sonatype, did a study last year that showed that about 70% of the time, dependency upgrades that are made by developers are suboptimal choices. And this study was done with 100,000 Java applications across 4 million component migrations. So that means that across this study, 2.76 million were poor choices, potentially leading to something that could be one day Log4j. We look at that in a bit of a bigger context. Maven Central has 70 million component downloads every single week. And if those are upgrades, that's the potential for 48 million bad decisions happening all the time across the software industry. And potentially billions every year of dependency upgrades that are something that could hurt you. The point I'm trying to make with all this is that developers need to start making better choices. And I shouldn't say developers particularly, but development teams in general. So what this study was based off of was some objectively bad choices that were being made, but also some subjectively bad choices where it's not always clear what the best answer is when upgrading, which is what makes it so challenging. So some of the objectively bad choices were, upgrading to alpha or beta releases, which vulnerabilities are often found in. And it can also, lead to using sometimes half-baked features. If you think about the JDK, there are a lot of preview features that come out that are subject to change. The next objectively bad choice is don't upgrade to a vulnerable version. But again, it's easier said than done, because that vulnerable version might not be in the package you're pulling in. It could be in a transitive dependency, like Log4j, for example. Next objectively bad choice, upgrade to a lower risk severity if your current version is vulnerable. And this is pretty easy if you just have a severity 10 CVE Log4j, I'm going to upload to the next one. But if you have, say, several medium vulnerabilities that are inflicting a package, that could become sort of challenging to figure out what exactly is the least bad solution here. And finally, the last objectively bad choice is, I should say the other way around, what you should do when a component is published twice in close succession, upgrade to the most recent one. There's probably a reason that it was published like that. But there's some subjectively bad choices too when it comes to dependency management. So, for example, you might want to stay on a common migration path to reduce build breaks. Choose a version that the majority of people are using, because believe it or not, there is studies showing that there is some safety in staying with the herd. And if all else is tied, choose the newest version to stay fresh and eliminate technical debt. So the point is, it's not just enough to wait for the next Log4j to come around. This is our modern digital infrastructure filled with open source technology is starting to look a little bit like this, and it can be unsettlingly dangerous if we don't actually know what's in it. There was a study done in the Cortex Expanse report showing that when a new vulnerability gets publicized, scanning by threat actors starts to happen within 15 minutes, which is way too fast for really anyone to be dealing with. The average development team takes 12 hours versus this 15 minutes. And so it's not really enough to just be thinking about what do I do when this happens, but how do I prepare in advance for things like this to happen? So the steps to take for that are, first of all, be choosing new dependencies wisely. Knowing what's in your application in the first place, that's kind of a non-starter. Assessing existing dependencies and making sure you're actually okay with the amount of risk that's in an application and those transitive dependencies. Continuously upgrading components, continuously monitoring for security vulnerabilities, and having a remediation strategy. Well, the first one we've touched on a little bit already, but that is how to choose new dependencies wisely. So we'll start with some, pretty reasonable guidelines. The reason a new library is probably being chosen is to solve an engineering problem. So does it solve the engineering requirements, such as the correct features, performance, scalability issues? Other considerations could be things like training cost and ease of use. Is it well documented? Is there a supportive community of open source engineers that will help you if you have trouble installing and using their software? And if that's not enough for the organization, is there paid support options or third-party companies that will support you if something goes amiss? Another thing to look for is project activity. Is it being actively maintained? And for those contributions, are they being reviewed with rigor, and are they quality code? Aside from these more sort of obvious guidelines, there's compliance and security to think about as well. But for choosing open source libraries, licensing is a hugely important one. Pulling in licensing that might be more restrictive than what you've committed to in your application, could result in legal implications. And security, again, is another one. So how quickly does the community react to a vulnerability when it comes out? Which version of the project is least vulnerable if I'm choosing which one to actually use in my application? And lastly, and I think one of the most important security questions is, does this hurt my current security posture? Am I taking on more risk by bringing this library into my life and my application? But in order to answer this question, of course, it's important to know what you're using in the first place. What, in fact, is in those transitive dependencies in that black box? It really brings us back to Log4j, and that just the fact that 30% of Log4j downloads were still vulnerable in the spring shows that doing this manually really doesn't work and is not the answer. And so one type of technology that's been becoming prevalent more recently is software composition analysis tools. And many companies are building free tools around this area. GitHub, GitLab, Sneak, Sonatype has one as well. And the purpose of these is to be able to identify these third-party open source libraries that we may be using and provide recommendations around what to do with them. So that could be around security, including choosing the best version of that package, legal compliance, code quality, and general project health. Now, you've likely seen these types of tools before, but one of the things I wanted to draw attention to is how they work. And just downloading and relying on something like this is really not enough, because not every tool is created and scanning equally. It's quite nuanced. So one thing to look out for is that there are different types of scans. So believe it or not, some scanning is simply potentially looking at a POM file and saying, oh, this must be everything that's being used, but that's usually not true. Other types of scanning look for those transitive dependencies more thoroughly by doing things like actually downloading the libraries and then seeing what comes along with it. This is an example of what one of these scans might look like, at least from the security point of view. This is what Sonatype does, but just wanted to point out that this transitive dependency information is something to look out for when choosing your own tool. Another thing you'll see quite a lot of, start seeing quite a lot of in these tools is something like this, export cyclone DX. Well, what in fact does that mean? So this is a sort of new standard of tracking dependencies called an Sbomb. And the reason that this has come into existence is just because scanning itself is so hard and can be very error prone. And so this concept of software bill of materials actually came from the manufacturing world. So if you think about it, if you're buying a car, you can reasonably trust that whoever built that car knows exactly the parts that were put into it when it was made, the versions, the types, so that if they find out one day that they didn't work, they can issue a recall and protect public safety. That's the same type of concept that's being applied here in the software world. It's important to know exactly what's in applications, and especially for third-party software, so that if I go to you and I say, hey, I want to buy your software, you can provide me this list, this bill of materials, so I can go through it and say, ooh, but you're using log4j at a bad version. I cannot buy this from you. You need to fix that. It's just a way for me of knowing what type of risk I'm taking on. For exactly, as I said before, that those scanning tools can sometimes be flawed. And so Sbombs are helpful for providing clarity around application dependencies, for tracking known and emerging vulnerabilities. So when something comes up and I need to know, am I using this package, I can consult my Sbomb. And for also helping make decisions on third-party dependencies and knowing exactly the risk that I'm taking on. So at least in the Sonatype world, we talk a lot about the software supply chain, and this is sort of the concept that the software bill of materials is built upon. I just wanted to touch on what this is quickly and what it means when I say software supply chain. That really is the process of building software in order to ship finished products. So I would compare the suppliers of a supply chain to third-party software like open source components, warehouses to component repositories like Artifactory or Nexus repository. The manufacturers are the software development teams, and the finished goods are the software applications. So back to software bill of materials. This actually came about through an executive order from the White House last year, where Joe Biden is trying to improve the nation's cybersecurity. And the regulation is that any vendor that provides software to a government organization will, by 2024, have to provide that bill of materials so the government can then assess the risk that they're taking on. Now, what does this have to do with all of you or with open source developers? Basically, 90% of components used in open source applications are in fact open source components, even if they're being supported by someone else or being packaged and redistributed. There is open source in most applications. So these projects will likely follow suit, and you're likely to see Sbombs pop up in more and more projects in the next few years. So what exactly does an Sbomb look like? This is the minimum number of elements that are defined by the executive order. So there's data fields to show things like the supplier, the version, when it was built. It's to support automation, so being able to create it automatically to be able to scale across software ecosystems. And also, the standard should define the operations of requests, generation, and use. So what is the relationship and how does it work when I ask for one, etc. And currently there are two types of Sbomb standards. So I don't know if you remember back to the screenshot I showed of Sonatype list scanning tool, but it said export Cyclone DX. So that is just one of the two most prevalent Sbomb standards that we're seeing right now. Just wanted to put this up there to show that you will likely see these terms floating around. And it's not really a question at this point of which one is going to win out over the other. I think it's likely that both are going to be used and be interchangeable as well. So the next version, as far as I'm aware of XPDX, is planning to be something that can be transformed between these two relationships. All right, so we've got our scanning tool, we got our Sbomb, we know exactly what's being used across the build system. Now, you have to assess was that actually what you meant to do? Is this okay? Things like, are there existing vulnerabilities that you maybe weren't aware of? What's their security posture like? And are they ready to take on the next Log4j? So again, the SCA tools, scanning tools, do a lot of this work, but I wanted to do a little bit of a deep dive into like how they're doing it and what they're looking at. So of course, the first thing you may or may not probably heard of is CVEs, which is Common Vulnerabilities and Exposures. This is a way of categorizing public vulnerabilities as they come out. And a vulnerability is a security flaw that can be exploited and is proven to have been possible. So these are pretty basic. They have an identifier and a description, but it doesn't tell you a whole lot other than that. So there's also a scoring system that tells how bad this may be. And that is called the Common Vulnerability Scoring System. That is a commonly used method. It measures the severity of each CVE and it bases them on ease of exploitation and impact. So Log4j, for example, was super easy to exploit and extremely impactful, and that one got a rating of 10. All of these can be found in the National Vulnerability Database, and this is where a lot of scanning tools, well, I should say likely all scanning tools are pulling from this in some capacity. But there's typically more data than this in a lot of those tools, and the reason for that is that there's a lot of money to be had in cybercrime, and so it's not always very motivating for a cybersecurity hacker to disclose their vulnerabilities. In fact, cybercrime is now officially more profitable than the drug trade, and it costs approximately $6 trillion in damage every year. And so a lot of these products, these scanning tools, actually have a team of hackers that are sort of working to fight against that and being a little bit more proactive than just using what's in those vulnerability databases. Another scoring system that's a little bit new, but you might also be seeing, is called the exploit prediction scoring system. And this one's kind of interesting because they're actually using machine learning algorithms to look at patterns of prior exploits and to figure out how likely it might be that certain CVEs could be exploited. So again, Log4Shell got a 90% chance of exploitation. So aside from being able to track what's already out there, another thing to consider in terms of security of open source packages is, are they ready to take on the next Log4j? So one initiative that's come out recently is the OpenSSF Scorecard, which is basically a GitHub badge and a set of scans that are run to check if packages are trustworthy and doing what they can to be prepared for a vulnerability. So this comes from the OpenSSF Best Practices Working Group, and their entire role is to help identify good practices, requirements, and tools that can help open source developers create and maintain more secure software, helping maintainers learn to write secure software, and providing tools to help developers adapt these good practices in their daily work, such as Scorecard. So the idea here is to help improve the security posture proactively of open source projects, but then also to help people who are consuming these projects to know that, hey, this project cares about their security stance. So this is just a brief example. These can be run in GitHub Actions or manually. This was a manual run I did to just sort of show the types of tests that are being run here. Some of them are more simple than others. It could be something as simple as, does my project have a license, in fact? And some of them can be more complicated, such as, do I have an Sbomb, which is a little bit of a more difficult question to answer. All right, so we know how to choose dependencies wisely. We know how to create an Sbomb and figure out what's in that black box of transitive dependencies, and how to assess whether or not they are vulnerable or risky. The next step is being able to continuously upgrade those dependencies. And this is important for a number of reasons. It can be for eliminating technical debt. Following upgrade patterns may help reduce risks of regressions and breakages. It could be retaining engineering talent. If you're using 10 and 20-year-old software, that might not be as appealing to newer developers as the latest and greatest, for example. And of course, security considerations, which keeps coming up as a theme in my talk, because as I mentioned previously, there is in fact safety in numbers when it comes to upgrading. So Sonatype did another study about what the best way is to be upgrading, and should you be keeping up with the latest or staying behind? And the answer is actually somewhere in the middle. So starting in the bottom left there, this is a bit of a clustered approach to dependency management, which is having manual workflows and not keeping up with the edge of upgrades. This can bring up a lot of technical debt and increase security risks and make it so it's really difficult to pivot and upgrade when major vulnerabilities come around. The next extreme on the right there is living on the edge, and that is just upgrading as soon as the next dependencies come out without any sort of context or nuance there. And while it is good to be staying close to the edge and upgrading frequently, it still can lead to security exposure and ultimately can reduce quality of life for developers, because this can be a lot of work. So the best one is, in fact, living close to the edge. So being smart about what you're upgrading, but staying relatively fresh as well. And this study actually showed that on average, the best version is 2.7 versions behind. Now that should not be a rule of thumb by any means, but just to give you an idea that the newest one is not always better. And then on top of having continuous upgrading, ongoing security scanning is important as well. So you've probably heard of DevOps. I know it was talked about quite a bit in the last talk as well. But the next movement and the buzzwords are shifting left and DevSecops. And what this means is making security part of the development process and not creating more work or asking developers to become security experts, but just being empowered to make decisions when they come about quickly. The downsides of having this type of model where security is in sort of a separate loop is it can be really slow, and security can potentially be a bottleneck in a very streamlined build and deploy system. It can also be really expensive to remediate if you're not getting feedback from the very beginning. And so that is basically the idea behind DevSecOps. Help developers make some slightly better choices, not living on the edge and creating more work for themselves, but also not lagging behind in terms of upgrades. Now, I know this is a developer conference, and again, I'm not single-handedly asking each of you to go implement this in your organizations, because that is, likely not possible depending on what level you're at. And so a key question that I get asked quite a bit is, how do I get my leadership to buy into this? So short answer is, be the squeaky wheel, keep bringing up the issues here. And the Log4j example is a great one, and so are some of these studies that I mentioned. And aim for improvements, not to be perfect. These types of systems take quite a bit of time to be done well. And we're not aiming to have DevSecOps in profession, but something like an Sbomb in an Excel sheet to start out with would possibly help in the future. And for the long answer, would be happy to chat about that later. All right, final step in this process is have a remediation strategy. And for this, the pieces kind of fall into place if you have the other pieces already done. So having an Sbomb, for example, makes finding vulnerable packages really easily when necessary. Keeping close to the edge of upgradings makes patches, when they come about and need to be done quickly, more of a routine. And finally, choosing with deliberation those open source communities to support you will help you feel good about the fact that you can rely on them when necessary. All right, so key takeaways from this talk. Again, working smarter, not harder, by having automated tools to help with these decisions. No, it's not up to developers to do this completely, but there is a bit of a shift in mindset in being able to think about these things sooner in the development cycle. Sbombs are coming. It's probably a term you'll start to hear more and more, so just something to be aware of. And finally, that security education is becoming a critical skill for developers. In fact, I saw a study that was done by the US government recently that basically categorized naive developers or untrained developers as an insider threat. So if that's not motivating to have some security education and just be aware of best practices, I don't know what is. So later in this conference, just wanted to give a quick plug for talks that are happening from my company. So we have The Secret Life of Maven Central, which is by Steve Poole, who gave the talk just before this. And this is a really interesting one because it gives a lot of behind the scenes of Maven Central, the service that we don't always spend a whole lot of time thinking about it, but has a really interesting story. And then I will also be doing one around Java coding best practices for security, in case you wanted to know more and not be that insider threat. And that's all I have. I believe there's a break right now, but this is the schedule for the rest of the day, in case any of you need to know. So thank you.